All right. Thank you everyone for joining. My name is Dmitry Vinnik, and today we'll talk about web testing. In particular, we'll try to kind of highlight the problem that most people face, especially in the big enterprises where we just think web testing implies heavy end-to-end, really focusing on Selenium and then bashing on Selenium and saying that our test infrastructure is so slow because of the tools we use. Instead, I'll try to focus on some best practices and how to actually solve these issues of flaky tests, fairly slow infrastructures, and that's basically what this is all about. But first, let me actually define the goals so you can make a conscious choice whether it's best to stay on this talk or go to any other great talks that are happening in parallel with mine. First and foremost, we'll discuss about establishing the right context, basically knowing what tests you're writing for, whether it's if you're API first and API only team, this talk is unlikely is for you. If you are really web heavy, UI heavy team, this talk might actually be useful. So it's important to understand the context, and that's what we're going to talk about. Then another goal of ours would be making sure that we choose the right and appropriate level of testing. Again, we don't jump straight into end-to-end, heavy, somewhat slow testing. We need to go down the test pyramid and take a look at, less complex tests like unit tests and integration tests. And last but not least would be actually talking about end-to-end tests and how to choose an appropriate approach for your team. Again, your use cases is what's gonna matter the most for this talk. All right. So first, it's important to go into some details, especially because it's as I said, it's not just about the tools, it's about the practices and the best principles that I personally follow and I've seen other teams like to adopt. So again, good question to ask whenever you kind of look at testing. How do we usually test? Because if you're talking about something new, it's best to build it on top of some fundamental knowledge that everyone already has. So how do we usually test? Test pyramid, as I've mentioned, is usually what guides us in terms of the structuring our test automation. And as you can see, and I'm sure you've seen this before, in the bottom layer, we have a unit tests. And the bottom layer implies, again, the width of this level implies that you're supposed to have the largest number of your test infrastructure built on this level. As we all know, they are usually the cheapest to write and to maintain. They're the fastest, but they give you the low level of fidelity. In other terms, they give you fairly low confidence level in overall quality of your product. So these tests are not enough, unfortunately. That's where integration tests come into play, and they're a bit more involving. They might involve the real application running, trying to see how multiple units of work, units and modules of your applications coexist and work together. So that's where this integration testing comes into play. And last, of course, something we're going to focus on more than anything during this talk is end-to-end tests. And they are kind of the polar opposite of the unit tests in the sense that they're usually the costliest to run, to maintain, to even write. They're the slowest comparing to the other levels, but they give you the highest level of fidelity. That's why it's the top of the pyramid, because it implies that you're supposed to have a very few number of those, because you're going to have only a very few number of real use cases. And that's where you're writing your end-to-end tests for the real use cases, the main flows that your customer is going through. That's why this level gives you the highest level of fidelity, because it's real use cases automated. So that's basically how our talk is going to be structured, because we'll try to tackle web looking at this pyramid in every single level and how you can automate your application. Okay, so again, how do we actually test web? Unfortunately, the test pyramid I've showed you is not the realistic one. I've never seen that in practice. In terms of the real test pyramid that actually exists in the wild, there's an anti-pattern called ice cream cone, there's hourglass, and something called a cupcake. It's a fairly sweet names, I'd say, apart from the hourglass. Unfortunately, it's not very sweet to deal with those. So in terms of the ice cream, though, I'm sure you've seen it in the past or heard of it. Some people call it reverse test pyramid, where basically it's flipped, where you have a very few unit tests, you have more service or integration tests, whatever you want to call it, and even more of UI tests or end-to-end tests, whatever your naming conventions are. And sometimes the icing on a cake, as you could say, is this large amount of manual testing. Whether you have it or not, it's not what matters. The most important thing here is that you have this reverse pyramid anti-pattern. And it's common, especially in the teams that I've seen where you have a very strong separation between engineering and testing, especially in Europe, in my experience, where they have sometimes different departments handling testing and engineering, where you finish your feature, you throw it over the fence to a testing team, and you only judge that testing team on a number of end-to-end tests that they write, because you don't allow them to be, this white box testing where they can actually see the production code. Instead, you just say, test it somehow, and however you want and you can. And unfortunately, for more often than not, they're only given tools to do the UI testing. So that's how we often end up with this anti-pattern. Hourglass is very similar, where it's kind of a bit better in a sense. You have more unit tests. But still you don't have the proper number of service or integration tests, and you have way too many UI tests. Usually we end up with this anti-pattern when we have a team that decided, okay, we have a reversed test pyramid. Let's now be test-driven development team. So we write a bunch of unit tests, but we forgot to actually talk to everyone in our department. Basically, if you have a different testing team, you don't really collaborate with them. You still keep doing this thing. You implement the feature, throw over the fence to them, and say test it however you want. And you're missing this important, again, cooperation piece where you actually discuss your strategy. So you don't have to have those UI tests for every single scenario, only the main use cases. So this is how we end up with this, unfortunately. And the last piece is the cupcake. I just like the name, honestly. In reality, what this anti-pattern stands for, where again, lack of cooperation results in people duplicating the effort. You have quite a few unit tests, integration tests, still lots of UI tests, but because people don't talk to each other, as you can see in this illustration, there is a great illustration of the wall between the teams. As a result, you have a large amount of duplication. And again, it's going to just put a strain on your infrastructure and doesn't bring really any value. That's basically in reality what we have to deal with day to day. I'm sure there are a bunch of other names for those cool anti-patterns, but that's about all for the real test pyramids that we encounter. So we actually need to change that because, of course, it's great to potentially do this job security where you deal with those real test pyramids on a daily basis. But in reality, if you want to make your life easier as a developer or as a tester, it's best to have those strategies in place and know how you're going to continue. And so when it comes to kind of changing something like that, and even in this talk, it's important to establish the context. Throughout today, I'll be showing some tools, and for that, we have to know what we're going to apply those tests to, what we're going to test. I'm not going to be extremely creative here. I'm actually going to be very plain and simple. The test example app is basically what every other person who shows or showcases any UI tools refers to. It's so-called to-do MVC app. Basically, it's the simple to-do app where you have a to-do list, changing the number of, you basically can create a to-do item, like brainstorm ideas, finalize abstract, you can change its status, you can delete it, lots of different simple operations. But it's, apart from the horrible contrast on a font, this is a great app to kind of showcase any tool you want, because it's implemented in different, frameworks, languages, whatever you desire, and it's a great way to showcase. And again, in these slides that I will share after, you can see, URL to this example app. All right, but back to the testing. Again, I've kind of established the context a little bit. We will be going through special case number 1. And the special case number 1 is what I personally had to deal with quite a bit, is when your backend written in Java, and so your testing team or developers who write tests in some cases end up writing tests in Java. So basically you say, okay, we have a backend in Java, let's do the testing in Java. If your team, as I've mentioned, again, the context matters here. If your team is very heavy UI oriented, web oriented team, I would say there is a problem with just doing this special case that I've just shown, where you have a backend written in one language and you just say, let's do our testing for the web using the same exact language, in this case, Java in the backend and Java for the testing. Basically writing your Selenium tests in Java, I would say there is a problem. And the reason why I say that and why I'm trying to kind of highlight this moving away from this backend testing, because you basically write your front-end tests using a backend that you have implemented for your production app. So why not backend testing? Why do I say that? First, I'll try to kind of highlight this new thing called hybrid model that's becoming more and more popular in the West. Domain-driven design, I'll just mention a couple of things about it. And the last point would be the user-centricity of this front-end test that we want to really implement rather than the back-end tests. So when it comes to hybrid model, again, it's just a fancy word. People like creating new names for things. I'm a big proponent that most likely people name things for the sake of the better resume and becoming the consultants. But in reality, this model is extremely simple. You just have everyone called software engineer. There is no, developer, tester. Everyone is the same. Everyone has the same title. Again, it's been known for a while. They just came up with this name for the model. In reality, what it means is you're using those software principles, the best practices that we all know and use on a daily basis. You apply those practices along with your testing expertise to really write software and to test that software. So you don't have those separations, as I've mentioned, that fence doesn't exist anymore between testing and developer team. Everyone is the same. Again, as I mentioned before, I go to quite a few conferences in Europe, and I've talked to quite a few people who work there. And there is sometimes a hostility between the testing and developer teams. To the very least, having the same title for everyone, I've seen that's kind of resolves these conflicts at its core. But also it helps to combine these both software principles and testing expertise and see how that works for testing infrastructure. For domain-driven design and why it matters for not writing backend tests, when it comes to domain-driven design, it's becoming more popular these days, or at least, even if you look at number of events that are happening all over the globe. Ultimately, what it all comes down to, these fancy three words, is the idea of ubiquitous language, where you are trying to speak the same language between everyone on your team, and also even outside the team. Basically, I want to make sure that when I name things, my project management understands me. When they name things, developers understand them. We speak the same language. We don't have to translate each other. To give an example, and another important point in the domain-driven design is the idea of context. For example, if we, as a company or as a department, working on an accounting system, and we have a class, Java class in this case, called account.java, that account is going to look very differently in my accounting system comparing to another team that works on authentication. Because account.java in authentication team would be very different. Because account and authentication, it cares about its session cookie, session ID, its rights and permissions to interact with the production system. If I have an account in accounting system, I care about my taxes, my credit score, all those things. So the context matters, and this is what really domain-driven design is about. So that's why it's so important to hybrid model, because here again, you're trying to have the same language between testers and developer team and the customer. And if your customer works with the web, with the UI, it makes sense to write your tests in the language that your customer technically understands and works with, is the UI. And so that's why I'm going to be trying to shift away from backend tests. And because again, most important thing here is to keep your test user-centric. It's not just end-to-end test that's supposed to be user-centric, basically real use cases that the customer works with. I'm a strong believer that every single level of a test pyramid is supposed to follow this principle of keeping it really user-oriented. So if you're still not convinced, and it's totally fine, it took me a while to even think about it, whatever works for you, totally fine. As soon as you establish these ideas of keeping it user-centric, and again, for modern web testing, what's important is to really acknowledge the power of JavaScript, because I've talked about Java for the backend, but again, the JavaScript when it comes to web is what we use the most. Of course, there are other ways to write web. And again, it's a Python conference. I'm sure you use Python for a variety of things, including for the web. But when it comes to JavaScript, we can't deny how important it is for the web these days. In terms of testing, and again, because this talk is about testing, we have things like assertion libraries, which empower us quite a bit. We have process methodology libraries, and kind of more importantly even, our enterprise libraries, because it shows the acknowledgement and kind of a commitment from real enterprises or companies that rely on the language. In terms of testing, assertion libraries that allow us to write our tests, we have things like Chai, Jasmine. I feel like whoever names those libraries, it was very thirsty and like keep going with that. Definitely there's a latte or some espresso for Android. Anyways, people like the drinks when it comes to the testing. Process libraries, when it comes to behavioral driven development, if you are a fan of that, JavaScript doesn't really hurt you in that case because it has Cucumber for JavaScript. Enterprise, things like Apply tools in terms of testing, they give you a power of visual testing for your web automation as well. So you are really not at a loss of number of tools and capabilities that JavaScript gives you. You have enough commitment from the open source and the enterprise here. Again, but the speaking language of the web, the JavaScript, and in our case for the tests that we will be looking at today, Node.js will play the most important role. And the reason why I say Node.js is so important is because it's isomorphic. In other terms, we can actually write it for both the client side and the server side. And in terms of tests, it's extremely important for us because majority of the examples I'll be showing would be using Node.js for that purpose. It's extremely flexible, and more importantly, it's very customizable. All those libraries I've shown you just now, you can easily import and use those capabilities, reuse them, so it can save you money and keep you focused on your goal. And that's all thanks to the, in this case, NPM Manager. I wrote this slide a while ago. Obviously, there are right now more package managers out there, but NPM was and still, I believe, is one of the primary package managers out there that allow you to import the new libraries and get those capabilities in your JavaScript. And again, it's kind of a great preface to our discussion. But looking at the pyramid again, when we have this idea of the context and why it matters to write your tests in a user-centric manner, if we look at the test pyramid, it's not just a test pyramid anymore, it's a web test pyramid. So, web test pyramid doesn't look any different from what we've seen so far for the regular tests. But an important thing behind your mind you should keep at all time. Every single test you write in this test pyramid should be user-centric, real use cases, real scenarios, or things that you're trying to think, okay, I've had end-to-end tests in the past written for this edge case. Let's try to take it down the level, or maybe 2 levels, all the way to the unit tests. So you're trying to basically get away from those anti-patterns towards this idealistic kind of approach. Still keeping the same principles of low cost, high speed, and low fidelity for unit tests. With that, I really want to talk about unit tests in a web context. So, first example, and again, I'm not trying to teach here how to write the tests or this particular tool. My main point here is to show you how flat or how simple the learning curve is. Because if you've written lots of server-side tests, backend tests, using whatever language in the past, here I just try to give you some examples of how easy it is to transition if you wanted to. Because every single test I'll be showing, like any other assertion test, follows the same exact principle of just 3 statements. You're trying to arrange your test data, then you act on that test data, and then you assert that test data, basically 3 A's. All tests follow this pattern. You're arranging the data, acting on it, basically executing something, and then you're making sure that the expectation that you set actually match the result of this operation. That's it, every single test. So with Jasmine, for the unit tests, imagine in our to-do application, we have a simple function, production function, that does whatever nonsense this function actually does. It takes the input, converts it in the proper format, and sends it back and displays it in whatever format the user wants. Ultimately, it doesn't really matter to us what this function does, but just to show you that it's a simple function that the production app has, there is no real reason to just write end-to-end test for this operation alone. It's fairly easy to automate that using the unit tests frameworks like Jasmine. So again, most important idea here, how easy it is and how comparable it is to whatever tool you might be using today. You define your test suite. Basically, test suite will be creating different to-do items, whatever way and shape we want. You define a test case. In this scenario, the test case accepts valid data. You give it a proper name, and the proper naming is great. This is inappropriate name, by the way, not in a not safe for work way, but you should never call a thing a valid data, because what the heck valid means. Please forgive me for doing that. But more importantly here is the same idea, defining things, creating a test case, and then writing the test itself. First statement, you are arranging the data. Basically, the data on the right that you see here, giving it a name and a state, that's the test data. When you call create to-do item, that's an act, it's an execution, it's an operation you're trying to test. And then you have the assertion step, the third step, where you have expectations and you compare the values. Again, the same kind of even syntax, the same, because we want to show how easy it is to transition. And the same three principles apply in Jasmine case as well. So nothing special here, and it doesn't make sense to write these tests for end-to-end tests alone, just to test this functionality alone. Integration tests. Again, you can exercise the power of user-centric tests without going all the way to the end-to-end tests scenarios. And integration tests in the web context, it's been quite a popular area these days, especially for different UI frameworks. In this scenario, I want to show you an important tool, Jest. Jest has lots of capabilities, but in particular, it's an open source library, I believe, from Facebook, from the open source team. But basically, one of the things I want to show you is a snapshot testing capability that Jest provides you. Okay, even if you're not familiar with React, ultimately, it doesn't matter for this talk. The only thing you have to understand is just the components, basically things that render on a web page and generate HTML for you. In the simple terms, that's basically what it does. Even though you write the JavaScript in this, this small snippet, you can see that it's potentially kind of, you can get it that it should supposed to generate a button HTML with certain class name, certain operation, and certain style. Of course, you usually would never do the style on like the same file, but again, it's just for the sake of demonstration. Ultimately, it's supposed to combine the style and the HTML and, create something for you and have the web app running. So what Jest does for you is that you don't have to test that the button is there, that it can be clickable, or it has a proper class names. You don't have to write end-to-end test scenarios for that use case. You can simply write snapshot test. And what snapshot tests look like, it's the same couple lines of code. You can create your own tests. In this scenario, you render that individual component. Our component was called create to do. You convert it to JSON, you save it to a snapshot, you assert it. Again, it doesn't really, the syntax here doesn't matter as much. It's the same syntax for majority of use cases. You can even press some buttons before you take a snapshot. But when I say snapshot, what I mean by that is this small piece of code. It basically, what it does, it renders that individual component, saves whatever its generated HTML and style looks like. And if you were to make any changes down the line for the, let's say you change the background color or you change the border or whatever, basically by doing that, your snapshot test would fail because it would say you haven't updated your snapshot. Were you expecting those changes? You can think of it if, I've seen it in the past, people do often, people write WebDriver tests to assert a certain CSS values. Is this navigation menu a certain color? For this platform, whether it's a tablet or mobile, Is it where navigation menu where I expect it to be? So Jest is it's a great integration test suite for individual components or maybe a couple components, but I would say never use it for the entire page because you will end up updating those snapshots over and over again. But again, if you reflect on those first two levels of unit tests and integration tests, the interesting thing about those were that we had a single focus for both layers, and the single focus was developers. And it's great for some tests. You know, as a developer, I want something that's fast. I want something that closes the feedback loop quickly. In other words, when I make a change or I fix a bug or do something with the code, I want someone to give me feedback quickly, whether it regressed anything. And that's where Selenium WebDriver tests usually end up being regression suites. So I, as a developer, I can't wait for those, minutes. I don't want to say hours, but I've seen that as well. I don't want to wait for that long to close the feedback loop, to hear that my changes actually regress something else. I can't. I don't have time for that. So, when it comes to quick iterations, I want it to be fast. That's why I reside on those two levels as a developer. But for end-to-end tests, it's not really for developer focus. It's still those three ideas are in place, but we have to shift our focus from developers towards customers. Even though I've said everything is user-centric for this test pyramid, still end-to-end test in particular, you're writing it for the web, for the customer, for the end user. And that's why it's called end-to-end test as well, not just because it's, you're exercising a certain flow from the start to the end, but also because that flow is what the customer will be interacting with. You can also argue that developers are also customers, and sometimes they are, but let's not go into semantics too much. But again, it sounds great, shift the focus, easy to say, but how do we actually do that? And that's where end-to-end task testing or user-centric testing, whatever you want to call it, comes into play. You're basically trying to move away from interactions, basically focusing on the interactions themselves, and instead focus on the tasks, logging in, changing password, those kind of tasks, instead of focusing on, in terms of the writing the code. I'm sure you've seen this thing called page object model. You try not to use that as much, and instead you use something called screen playing pattern. Again, the semantics and the, those fancy names. Ultimately, what it comes down to, you're trying to write your tests ideally in a way where your customer or your other stakeholders in the team, project managers and business people, kind of can comprehend what you're writing. I'm not a fan of behavior-driven development here. I'm not saying write your test so everyone can contribute and rewrite it if they wanted to. No, it's that you don't write your test in a way where you say send keys, username. Instead, you say submit form, press button. You write the language, that idea of ubiquitous language that other people can understand. You can have a better onboarding. That's even another goal you can achieve apart from keeping your test user-centric. So if you were to look at our app, when it comes to end-to-end tests, what is the most common way to do end-to-end tests? And I've said it multiple times today, it's Selenium. Selenium WebDriver is an awesome open source tool. It's a de facto end-to-end tool. I'm honestly speaking, I'm going to bring up other end-to-end tools today. And it's been a bad practice when people try to introduce something new out there, especially in the open source, they would try to bash on the Selenium or some other open source tools that have been in use for a while, saying it's slow, it's horrible, it's destroying your infrastructure. I'm not going to say that. Instead, I'll actually acknowledge how important Selenium and the team behind Selenium was for the entire testing industry. Because again, it became de facto end-to-end tool. It established those testing standards. Keeping it generic, meaning that most of the teams out there that do the web, and sometimes even performance testing, I've seen that's been done as well. You can use Selenium WebDriver for that. And there are so many integrations, whether done by open source or the enterprise. Whatever you want is available for you. So Selenium WebDriver, really architecture-wise, they keep it simple, at least in this diagram, even though there was a lot of work put into place. But basically what it comes down to is to have individual bindings for different browsers. They have remote control server in between, and more importantly, which gives a huge power to developers and testers is the idea that you have different language bindings. So they don't say you have to write your test in Ruby, you have to write your test in Java. You can write it in whatever way you want. So Selenium WebDriver is extremely flexible for the users. But because, as I mentioned before, often people would use WebDriver using the language of the backend. Here, again, as I've said before, I try to focus on the web using the JavaScript, the language of the web, as I say. And it's important, by the way, that to have this capitalization, because JS, both capital, is a different framework. So it's important to keep it WebDriver J capital, S is small. Or you just go to Selenium HQ and you find it there as well. But ultimately, what it comes down to, this Selenium WebdriverJs, it's the same idea. It's the same team, exactly the same everything. It's Defacto end-to-end tool, testing standards. It's generic, lots of integrations. Because again, it comes from the same exact team. And it even looks the same architecture-wise. The only difference is, and the reason why it has different name, it's written and it only allows you to use Node.js for this particular implementation. So, in terms of writing the tests, and again, I'm just trying to show you how simple or how similar it is to writing your tests if you've used to using C# or Java, whatever it is. You name your test suite. In this scenario, this basic piece of code, just have to sometimes copy paste. It's basically a setup and the tear down clauses. You have to create your driver. You have to close it afterwards. It's all great. You having your actual test case in place. Again, you're trying to create to-do item, as I've shown you before, using the valid data. You go into URL the same way you would do it in whatever language you've used to. You find the elements the same way you've done it in other languages, and you do some assertions. You basically wait for the element to appear. Nothing special. Again, just to show you the same syntax, the same way of writing. In this case, I had to use awaits. You don't have to anymore. So it's just small snippet of code to show you that it's exactly the same. So there's not that horrible steep learning curve in place here. Unfortunately, there are not just good parts when it comes to testing, even in the WebdriverJS scenario. There are complexities when it comes to end-to-end tests. Hence, we even have to have this talk. It's how we find selectors and how we locate them. What is the strategy? What is the test flow? How do you write tests? And sometimes more importantly, for what single page application type of framework was this test framework intended to? Basically, is it for Angular? Is it for all of them? Is it for React, Vue, and so many others? So what was this framework created for? In terms of WebdriverJS, fairly simple. The same selectors you probably used to ID, CSS, XPath. You find it by locators, basically by dot ID, CSS, XPath, basically the previous kind of a highlight. The test flow, we used to have something called Promise Manager, which was extremely important for JavaScript users because especially with Node.js, sometimes it's tricky to deal with asynchrony because again, you're trying to keep it simple. You try to keep your test as simple as you can because you don't want to test complex production code with even more complex test suites. So try to keep it simple. And Promise Manager allowed people to write their code, the test code, top to bottom, basically in a synchronous manner. It's not in place anymore. It's been even optimized more than that. So you're in a good position, right, to get started. Spot types, of course, it's extremely generic. So easy to get started with WebdriverJS as well. But it still looks limited because we sometimes want to have a more specific tool. Is there anything better? That's why, again, context matters. What's it better for? It depends, as any other consultant would tell you. Angular, let's say you have a Angular app, production app in place. It basically implies you have a bunch of weird, HTML tags and like attributes like ng-class, ng-repeat, and ng-model, ng-change, things that normal HTML usually doesn't have. So how do we test that? Of course, you test it with the unit test, integration tests. In terms of end-to-end tests, you have a choice. You don't have to just use WebdriverJS. You can use something better than that. or at least more specific, Protractor. It's basically the end-to-end test framework for Angular apps, created and maintained by the same team that creates Angular. So you have this kind of inside connection. In a sense of the architecture, and that's what highlights this inside connection a bit. You have everything that WebdriverJs has. Basically, it's built on top of that with additional API. You have the same Selenium server in place, again, from Selenium team. And more importantly, additionally to the WebDriver APIs that Selenium provides you, it has access to the AngularJS app state. Was it loaded? Can I use it? Is it ready to be tested? That's what the inside Angular gives to Protractor for you to write automation for it. In terms of complexities, for Protractor, selector-wise, it has a special element bindings that I'll show in a second. Locator strategy, it has by repeaters, by models, whatever you desire. Test flows, again, application state aware. It knows when app finish loading, which is extremely important for robustness of your tests. And again, it's somewhat Angular. It's actually extremely Angular oriented. Test-wise, again, the same exact principles of you going to the URL. This is what I want to highlight. You can do the by model location. You can do by bindings. So it's very similar to the whatever you're used to. The same exact principle of arranging, acting, and asserting data, but with some additional kind of syntax to help you out. So Angular is great and all, but there are so many UI frameworks, right? There is React, Vue, Ember, Backbone, and I probably will spend a day at least, reciting a couple of other UI frameworks out there because they're popping up like, mushrooms after the rain, whatever they say. So, can you use Protractor in React? You sure can. You can just disable synchronization, which means you don't have to wait for the Angular app to finish loading. But honestly speaking, it's useless because you're not going to be able to use the bindings, models, repeaters anymore. So that's what you have to really consider when you're trying to switch to Protractor. Am I going to switch to UI frameworks in the future? Am I fully committed? It's things you have to consider. So what's next for us? Again, you don't have to just use Selenium tools like I've shown you. There are non-Selenium tools in place as well. There's a TestCafe and there is a Cypress.io that's been getting a lot of press lately. It's been quite popular with developers. So what have we learned so far? Because I've showed quite a few things so far. Patterns. There are patterns for every single tool I've shown you. Common patterns for those non-Selenium UI test automation frameworks. And those patterns are: how do we handle waits? How do we execute our tests in parallel, or for what browsers? How do we do so-called rapid test development? We want basically this kind of a hot swap or kind of approach where as I change my test, I want the change to be applied right away. I don't want to restart my automation over and over again. I want those changes applied instantaneously. So how do we simplify that process? And because so many teams, and I've shown you before with those anti-patterns, still have manual automation, manual testers in place, manual automation. You still have manual testers in place. How do you transition them slowly to somewhat give them tools to do automation as well? Recorders where you press and you replace certain actions is extremely useful in that case. So the TestCafe in particular, in terms of patterns, how does it handle wait? It just waits for all the XHR requests to complete. That's can be tricky if you have a streaming kind of a request where it's constantly pulling some data out. So it can be tricky, but honestly, it just simply waits for all requests to complete, and then it starts running your automation, starts exercising and asserting a certain state of your app. It can run your test in parallel, and more importantly, TestCafe allows you to run your test for all, even non-Chromium based browsers like Firefox. Unfortunately, with Cypress, it's not the case. It's only Chromium based. Whether it's Chrome, I think Opera is also Chromium based, if I'm not mistaken, but Brave and a bunch of other browsers. And if it really matters for you, sometimes you have to use something like a TestCafe for different browsers. Rapid test development, I'll show you in a second. They have a great tools for that as well in terms of the IDE and the nice kind of flow of a test, test fixtures. And more importantly, for some teams, is they have a capability of record certain actions and then replaying them. To give you an example of how you would write code, nothing special here either. You figure out a test suite by establishing a certain URL you want to target, then you write the test itself. It's more about this so-called, like people sometimes call it a stream pattern, or basically, or you can look at the promises in JavaScript. Basically, after this operation finishes, it goes to the next level, and then it goes to the assertion. Basically, trying to combine each operations together to make it more readable for some teams. In terms of the recorder, nothing to see here really. It has like a special ID that they built for you. You can just, you know, do some manual testing, then replay it later on in an automated way if you wanted to. You can export those scripts and run them in your CI if you'd like. And they have a great documentation these days as well, which I really appreciate. In terms of the Cypress IO, again, it's very similar. It handles weights the same XHR weighting approach. It can run tests in parallel, but unfortunately only for Chromium-based browsers, as I've mentioned. But they have a great rapid test development practices in place. And if you've ever tried Cypress, you would definitely appreciate that. And they have basically ways to record tests as well. It's a different kind of a library that's available outside of a Cypress IO, but you can you can create your automation based on the actions that you performed. In terms of the example, it's very similar. You choose the URL to visit, you choose the operation to do. You can even operate with the cookies, as you can see here. So that's the tools and syntax that Cypress allows you. Nothing special here, it's just to show you that it's simple to transition if you wanted to. Recorders, or just ID itself, again, it has a nice integrations with whatever ID you use, and you can see those changes as you go. You can set the pause, similar to debugger statement in JavaScript, and see how those changes applied for you. But again, more importantly than that, with all those tools highlighted, is to choose the right tool for the right problem. There are many test frameworks out there: WebdriverIO, Nightwatch, VD, Nemo, and lots of other ones. You have to avoid mixing up the tools though, because it increases the complexity. Now you have to learn a bunch of tools to even get started. There is no domain-driven design, no ubiquitous language anymore, because again, you're trying to establish this common language between the teams. If you have different tools and languages within the testing department, you're going to be doomed really quickly. So how do you choose? That's an important idea of how do you choose those tools. Some people look at the GitHub stars. Some people look NPM downloads, basically, especially with Node.js, it's extremely handy. You can see how many downloads a certain test library, certain tool had. Other many integrations from the external market, but more importantly, try to do some proof of concept before you fully transition. So, more importantly though, to complete this talk, it's to choose a flexible tool that matches your use case. In terms of flexibility, really, it's all about the cost of transition and return of investment. Does it worth for you to transition to this JavaScript first approach? Maybe you're already safe and sound in your whatever automation you currently have. Can you customize it? You know, Protractor is tricky to customize to use for React. So maybe keep it to WebdriverJs. Think of that. And can you replace it easily? Those are the important flexibility concerns you have to acknowledge. But the last and more important, again, it's your individual use case. Does your team know JavaScript? Is it, again, web first team? What's your expertise like? What application framework you're using? If it's Angular, yes, Protractor might be the case. But if it's more generic than that, maybe Cypress IO is a good approach. Maybe start a new project, a new module, automated using Cypress, but the rest, keep it WebDriver. So again, sometimes you have to think of the test infrastructure. Can you write and run your tests using different tool? Is it set for that? Maybe you need to use some external services like Sauce Labs for running different browsers and different maybe mobile devices automation in the cloud or wherever you want to do it. So I want to complete it all with just a simple call for action for you. Really evaluate your test architecture that you currently have in place. Try to establish the domain boundaries. Know what you're testing. Unify your test strategy, and more importantly, experiment. Try out new things and new tools and see what works for you. Don't just blindly take a tool or my word for it. give it a try and see what works. Thank you so much. I'm not sure time. Let's see. 30. Yeah, the next talk is at 35. Are there any questions? The slides are all shared. I have a more extended version, which has like some demos and actually giving people a chance to play with things. So if you're interested, I'll also share that as well. You can see that I was plugging my Twitter and the website quite extensively. So if you wanted to, you can connect with me here and I'll share with everything on all those resources. So